Hello everybody, this is Dr. Christopher White, and in this video we're going to be looking at exercise 10 from Interpreting Earth History by Ritter and Peterson. Okay, so to begin with, let's turn to page 143. So obviously on page 143 we're going to find the title, Patterns of Evolution. We're going to find the learning objectives in the purple box. And then we're going to find several paragraphs of text on page 143, page 144, and page 145. Now, this is an explanation of the basic patterns and processes that we see in evolution, and I would strongly advise you to read this information. Because if you read this information, it is really going to help you when we come on to answering the questions. Really is. Plus, it's good information. It's going to help you when the time comes to answering exam questions as well. Okay, so we're going to start with part A. So part A is focused on figure 10.3. And we'll find figure 10.3 on page 147. Here it is. So, what does figure 10.3 actually represent? Well, figure 10.3 actually represents a sequence of 8 layers of rock. The oldest layer is T1, and the youngest layer is T8. So we have a sequence consisting of 8 layers, and each of these shapes represents a fossil. So as we can see, for layer T1, there were 4 fossils. For layer T2, there were 7 fossils, etc. Okay, so that's the basic idea. So what are we trying to do? Well, what we're going to do is we're going to try and spot patterns. Because if we can spot the patterns, that's going to allow us to link fossils together in different layers, and it's going to show us the evolutionary path taken by certain species. Okay, so let's go back to question 1, and it says begin with the oldest series of shapes. That's going to be layer A, okay, which is this layer down here, A1, A2, A3, A4. What we're going to do is we're going to connect, we're going to work upwards, should I say, connecting by pencil lines connecting by pencil lines or identifying by letter and number the likely phylogenetic series in each successive layer. So what all we're trying to do is we're trying to link together fossils from one layer to the next by looking for similarities. So, okay, let's go from layer T1, well, should I say T1 to T2. Okay, so that's layer A to layer B. So what we're going to do is we are going to try and look for similarities, and we are going to try and link together certain fossils. Okay, so we're going to actually skip A1 and we're going to start with A2 right here. So A2, as you can see, consists of a circle with a dot. Okay, so if you have a look at these 7 fossils here, can you see any fossil or fossils in this layer here that bear a striking similarity to A2? So I'm going to give you a second to have a think about it. And the answer is, well, yes, there are 2 very obvious candidates, aren't there? Now, the first thing is it would really, really help me if I had my ruler at hand, which I found. And so, obviously, A2 is very similar to B2 and B3. So, we can say with, relative certainty that B2, B3 are related to A2. So, okay, what we're going to do is we're going to draw a pencil line. I'm going to link them together. Okay. All right. So, what about A3? Well, A3, as you can see, consists of a triangle with a cross in the middle of it. Okay, so is there anything in this layer that looks like A3? So once again, I'm going to give you guys a second. Okay, good. I'm hoping that you've spotted that B5 looks rather similar to A3. So we would put a line linking A3 to B5. Okay, good. Okay, what about A4? Well, A4, as you can see, is a square with a cross in it. Can we see any fossils in this layer which bear a resemblance to A4? Okay, good. The answer is, of course, there are 3 of them. Obviously, B4, B7, but also B6. B6 is still, once again, a cross in a square. So it's exactly the same. Slightly different shape, but it's the same pattern. So we would have A4, and we would draw a line to B4, B6, and B7. Okay, good. Now finally we have A1. So are there any fossils in the B layer that bear a resemblance to A1? Well, the answer is yes, it's B1. Now, although there are the similarities aren't particularly striking, what do we have? Well, here we have a 5-pointed shape, don't we? And here we have a 5-pointed shape. So that's the relationship we're looking for. So we would draw a line linking A1 to B1. Okay, and so this is what we would do, working our way up through the layers, okay, connecting the fossils in each layer to a similar fossil below. So, for instance, once we've finished the B layer, then we'll obviously try and connect fossils in the B layer to the C layer. So, for instance, we would have B2, now as you can see is a circle with quite a large circle in the middle of it. So obviously we'll connect B2 to C6. B3 on the other hand, well, B3 is a circle with a small dot in the middle of it, so we would connect that to C5, wouldn't we? This square here with a cross and a circle in the middle of it, well, that would clearly be connected to C2. B5 goes to C4. B5 would also probably go to C7. B6 goes to C3. And then we have to work out, where does C1 and where does C8 end up? Now, this is where we have to, I think it's pretty fair to say that C8 and C1 would probably go to B4. Now, one of the things you're noticing, and you might have thought, hold on a minute, I don't agree with Dr. White here, and that is perfectly okay. Because one of the things that's really good about exercise number 10 is when you do this, there are actually quite a few different ways you can do it. So as long as you're making a logical argument, I can't take marks away. So, if you start connecting B1 to C6, well, obviously, okay, that's not going to work, is it? But as long as you're making logical connections, so if you relate C6 to B3, well, okay, I would have said B2 was the better choice, but if you think it's related to B3, well, it's still, kind of correct. Can't really fault it. So, I wouldn't be able to do anything about it. I would have to accept your answer. So, this is what people love about exercise number 10. The fact that it's very, very difficult to actually drop marks as long as you just spend a few seconds thinking about things. Okay? Now, when we were transitioning from layer B to layer C, one of the things you might have noticed was this. We found a connection for B2, B3, B4, B5, B6, and B7. We did not find any fossil in the C layer which connected to B1. So what does this mean? Well, this clearly means that B1 became extinct at this point. So we're going to make a quick note of that in the diagram. So what we're going to do is we're going to put a little mark, something like an asterisk, okay, next to B1, just to say, okay, B1 is one of these fossils that essentially doesn't go any further in the sequence. It became extinct. Okay, now there's one final thing that we can do, which is going to make everything a little bit easier. Now, it says use a pencil. And when you're initially making your lines, using a pencil is a smart move. But once you think you've got it pretty much down, I would strongly advise coming back to the beginning and using coloured pencils. In fact, using 4 coloured pencils. So let's say you start with the A1 is green, B2 is red, A3 is orange, and A4 is purple. And then draw these lines in colour. The reason for that is it's going to make my life epically easier when it comes to marking this. So I would really appreciate it if you were to do things in colour. Okay, and so that would mean every fossil that's related to A2 would be, for instance, in blue. So you'd have a blue line here, blue line here, blue line there, etc. Okay, so you'd have blue lines coming all the way to the top, orange lines coming all the way to the top, purple lines coming all the way to the top. Well, poor old A1 and B1, I didn't really go any further. Okay, so you'd have what did I say? Did I say red? Who knows? You would have maybe a red line here, and that would be it. So by putting in colour, that makes my life a lot easier, and that makes me a very happy professor. Okay, so what's next? Well, next is part 2, where it says tear out or copy the pages, cut out the fossils and rearrange them into patterns. Well, do you know what we're going to do? We are not going to do part 2. Okay, so once again, you guys have a relatively limited amount of time, so we're going to skip part 2. Okay, and we're going to go straight on to the next questions. All right, so on page 146 we have question number 3, question number 4, and question number 5. Okay, so question number 3 wants us to identify by number and letter. So remember, for each fossil there is a letter and number code. Okay, and it wants us to identify examples of the following: convergent evolution, parallel evolution, divergent evolution, and radiating trends in the evolutionary pattern. So for instance, if you wanted something like divergent evolution, well, you could say something like A4. So A4 goes to B4, B6, B7, so instantly straight away you have an ancestor producing diverse descendants. And then obviously you can continue on from there. So, so you could, in here you would write, for here you would write something like, you would write divergent equals A4 to B4, B6, and B7. And that would be it. That would be one of the 4 things you'd have to write for number 3 here. Okay, so that's a relatively simple one. If you don't understand what convergent, parallel, divergent, and radiating mean, number 1, you can refer back to the lecture, and number 2, you can refer back to the wonderfully written and highly detailed text at the beginning of the exercise. All right. So next we have question 4. So connect the various series with arrows to show trends. Indicate with asterisks those lineages that become extinct. So obviously we've already marked out the fossils that become extinct, so that's great. And so all we're doing is we're just simply showing, using arrows to show the trends. Okay, so we're just simply saying, right, using an arrow, this is the way this is the way evolution is going. So in the case of A4, we're just going to use an arrow. So right, A4 goes to B4, B6, and B7. Okay, to be honest, it's a bit of a pointless question, but hey, well, it's what they want. And then question 5 is the dominant mode and tempo of evolution in the relationships shown in figure 10.3 gradualistic or punctual. Okay, so once again, if you're uncertain about your terms, you can look at the lecture, or you can refer back to the text at the start of the exercise. Okay. So, did I say punctual? I meant punctuational. Don't know why I said punctual. Okay, so that's part A. And as you can see, part A, we're doing everything with the exception of part 2, which we're going to skip. All right. So the next part of exercise 10 is part B. And part B is on page 149. And so in part B, we're going to do exactly the same thing that we did for part A. But this time we are going to be using real world examples. So here it is. Okay, so these are graptolite fossils. And so graptolites were a type of colonial organism. Think of them kind of like the way corals function. They've got lots of little chambers in which individual organisms live. And what we're seeing here is we're seeing the framework on which the individual organisms lived. Okay, because obviously the individual organisms, well, they die and decompose, but the framework gets left behind. And we can find these fossils in rocks. I believe graptolites are quite common in rocks of Silurian age, but I could be wrong. I think they might be Silurian, maybe into Carboniferous, so I think they might have had quite a large range. I'm feeling very unconfident now. I'm going to have to check that. Okay, so what we're going to do is we are going to try and do exactly what we did with figure 10.3. We're going to try and link fossils from one layer to fossils on the next layer. Now, as you can see, layer A here has just one fossil in it. These 3 fossils are layer B, C, D, E, etc. So obviously, layer A to layer B, well, it's got to be A1 to B1, hasn't it? You can't really muck that one up. And then when we go from B1, well, B1 clearly goes to C1. And then you could argue maybe, now once again, this is going to be your own personal choice, you could say maybe B1 goes to C2 and C3, because they have this kind of drop shape like C1, don't they? They have fewer of these fine lines, so they're made of coarser lines, but you can see the general shape is actually similar, isn't it? Now, if I come over here and look at these fossils, what do these fossils all have in similarity? Well, they all have this little line right there, don't they? And they share that with fossil B3. So there's a reasonable possibility that B3 is related to C4, C5, and C6. You could also argue, if you wanted to though, maybe you could say, well, I don't know, maybe I feel that B2 is related to C6. However, if you feel that, C1, C2 and C3 are related to B1, and C4, C5, C6 are related to B3, well, obviously that means poor old B2 became extinct. Once again, you would mark this with a little asterisk just to show me that this became extinct. Okay, then you're going to work your way up through the sequence. So there's a few things you're going to notice as you come up through this sequence. Now, one of the things you're going to notice is that some fossils suddenly appear out of nowhere. So let's take D2 as a lovely example of this. So look at the C layer. And then all of a sudden, D2 appears. Well, D2 is essentially just, it's an oval, isn't it? It's a black oval. There's nothing even resembling that in the sea horizon. So what we seem to have here is we seem to have an organism that's come in from an external location. And this is perfectly logical. If you think about it, a location isn't a closed system. Organisms are perfectly capable from coming in from other locations and establishing themselves in that environment. So the arrival of D2 is a realistic event. And so what would we do? Well, clearly we would have individual colours, one colour for those species that are derived from B1, one colour for species derived from B2, and one colour from species derived from B3. So we'd have maybe red lines for this, blue lines for this, and green lines for this, for instance. So what would we do with D2? Well, we would pick another colour. We'd say, right, purple. And then obviously we'd go D2 to D2 to E7 and so on. Okay. We can also see the same thing happening in layer F. Now I'm not going to tell you which one it is, but in layer F you will suddenly see that one of the fossils in layer F really looks very different. Doesn't really resemble anything in any of the layers below. And so we have to say to ourselves, right, well, this probably is a fossil that's come in from outside the environment and has established itself. So once again, that would qualify for its own colour. All right. And obviously we can see similar fossils for, whatever this mysterious fossil is in layer F, we can see fossils that bear similarities to it in layer G and layer H. Okay, so once again, please bear in mind, use the colours again, just like we did in figure 10.3, just because it makes my life easy when it comes to marking. If an organism becomes extinct, put an asterisk next to it. All right. And don't be afraid to say, hold on a minute, I don't think this fossil really resembles anything else that I've seen in the layer below, and so I think this might represent an organism that's come in from an external location. Okay. I should also point out, by the way, so let's look at layer E for just a second. Let's compare D6 and E6. Well, you can see they do bear similarities, don't they? They each have this little line there and there, and you can see they each have this kind of these rather chunky double appendages there and there. But in this case, in the case of D6, they're orientated downwards. In the case of E6, they're orientated upwards. Now, as you can see, there is a difference in the orientation of these limbs. However, that doesn't really matter. They are, on the whole, rather similar, just that these limbs are orientated down, these limbs are orientated up. So you would probably link D6 and E6. Okay? Once again, it's very difficult to get marks taken away, to get wrong marks, incorrect marks on this particular problem, because as long as you're making a reasonable argument, I can't say you're wrong. Okay? So once again, think about what you're doing. I mean, obviously, if you try and do something like you try and link C1 to D2, clearly, obviously, I'm going to spot that and I'm going to go, no, you've made a mistake. But as long as you are logical and you say, right, C5 goes to D4, that makes perfect sense. Something like C4 goes to D7, that makes sense, etc. Okay? So, just like part A, you are also then going to try and locate examples of parallel evolution, convergence, divergence, and a possible polyphyletic origin. Okay. So once again, if you feel uncertain about these terms, you can look at the lecture material and you can come back here and look at the text. So there you go. There's the word polyphyletic. That's right there. Okay. So once again, if you're uncertain about the term, just come back here. There it is, right there. Just got to read about it, or there's always good old Google. Okay, so we can see that exercise 10 is rather straightforward. Now, then we come on to part C. Okay, now part C is a exercise that I have used in the past, and I've got to be honest, it doesn't tend to work quite as well as I would like. So I think we're actually going to skip part C, and so we won't be doing part C. Okay, so we're doing part A and part B, but not part C. We will also not be doing part A 2. Okay, we're not doing that either. Okay, so exercise 10 is a nice, relatively simple exercise. All you have to do, if you want to get a decent mark, is read the text at the beginning of the exercise and when you are doing your diagrams here, just spend a second and be logical. Okay, as long as you are making logical arguments, I can't say you've done something wrong. All right? Okay, that's it. So, have fun. Exercise number 10 is once again one of those exercises that often goes down very, very well. People tend to enjoy it. So, have a good time and get some marks. All right, everyone, take care.